Standard gates such as Pauli gates and CNOT gates are defined in Cirq operation. However, if you want to use a unitary, which is not a standard gate, for example, this matrix, you will need to create your own custom gate. Since all quantum gates must be unitary, we need to first verify this matrix is unitary, and it is very simple to verify this. We take the U dagger, multiply with the U, and perform straightforward algebra, and indeed it gives an identity matrix, so U is unitary. Let us show how to build a custom gate in Cirq. First, you import the necessary libraries, and then you define a class, give a name, for example myGate, and inherit this gate module from Cirq. You use a built-in function _num_qubits method to tell Cirq that this gate add on a single qubit, and you use another built-in method _unitary method to define the unitary of your gate, and then you use another built-in method _circuit_diagram_info to tell Cirq how to display the gate in the circuit. So once your gate is defined, you can use like any other standard gate in Cirq. For example, let's define a single qubit, and then I can define the quantum circuit using my own custom gate acting on the single qubit. And if I plot out my circuit, it will look like this with the G over here, and then I run the simulator and I print out the result. Indeed, it gives us the correct value. This concludes the video on how to build a custom gate in Cirq. The code can be downloaded below. If you like to feedback on the video, we welcome your comments below. If you like this video and find it useful, please share and subscribe to our channel. Thank you.